Thank you, everybody, for joining us. I'm very excited to be sharing this session about Tableau and Firebolt with you tonight, this morning, this evening, wherever you are. So let's get to it. We'll cover a variety of things today. The idea is to get you acquainted both with Firebolt and what it has to offer for Tableau. So we'll talk about Firebolt. I will highlight what our differentiators are in this market and what the benefits are for Tableau users. And we'll also do a demo. I'll show you how a Tableau dashboard works with Firebolt, and I'll show you a little bit how Firebolt looks like, and also share some insights on how typically PLCs look like at Firebolt. So let's get started. So Firebolt is a recent entrant to the exciting cloud data warehousing space. We emerged out of stealth mid towards the end of last year, targeting really companies that have bigger data challenges in the cloud, and came in really to shake things up a little bit in this market. We see ourselves as starting where the modern breed of cloud data warehouses and query engines sort of end. If you look at this middle section in the slide, it's no doubt that it represents exciting years that the data space has been going through. Those last maybe 5 to 7 years, ever since Redshift came out as the first cloud data warehouse, and other technologies followed, like BigQuery and Snowflake with their amazing IPO, and Athena and other technologies as well. There's no doubt that these have allowed us to scale to larger data sets and have made working with warehouses easier than before. But on the other hand, we also know that if you're dealing with ever-growing data sets, just being on one of these modern platforms doesn't mean that your data challenges are over. Far from it. And that's true in general for bigger data challenges, and also in particular for BI tools trying to connect to these technologies and enable fast interactive analytics. And Firebolt came into the market understanding that there's still a lot of gaps to fill. And we came in with a technology that can handle more data much faster than the others, while keeping things super simple to use and cost effective. Our differentiators are these three, and we'll spend some time on each of them. First of all is speed. We love saying that we're the world's fastest cloud data warehouse because we are. We come from a very deep DNA of high-performance databases in our background, many of us of the core sort of founding team. And you'll see it in action very soon. The second differentiator is scale. So, as we came into the market and sort of thought, what kind of architecture will be the most scalable, most elastic, then we ended up building our platform from the ground up with decoupled storage and compute in mind, which is the kind of architecture you want for the modern day and age. It allows you to really scale up and down with a few clicks, mix and match different compute types over the same copy of the data. So we'll talk about that as well. And finally, it's efficiency. Efficiency for us means not just being super fast and scalable, but actually being able to do that without needing huge clusters, expensive and CPU-rich clusters. At the end of the day, with cloud data warehouses and cloud query engines, it's all about compute. Essentially, the vendors are reselling compute to you, and it cannot be cost effective if your queries need a lot of horsepower. So we will talk about that as well. Now let's start with the first piece, which is speed, and talk a little bit about what's out there today. So just to set sort of context, if we look at the market today and sort of analyze the performance. So first of all, Snowflake, Query, Redshift, BigQuery, very comparable, a very close race. I like showing this benchmark. If you Google benchmark Snowflake, Redshift, BigQuery, you typically in the first result you'll see the 5-trend benchmark. So these guys do a great job in reiterating on that benchmark every year. So it's pretty up to date, and they run it over a 1 terabyte data set, running over the TPC-DS benchmark, which is a sort of well-known data warehousing benchmark. But what you can see here is that already over 1 terabyte of data, the median of query response times is 8 to 11 seconds, which is not great for interactive analytics, especially not if you have a dashboard with many charts in it all competing for the same resource. And if you look at the histograms on the right, you can also see that many of the queries in the benchmark actually take much longer, over 20 seconds. And that's not a fun interactive experience. And Firebolt is all about delivering sub-second performance over this kind of data volume and much more than that. And we will see it in action. Now, let's talk a little bit about, before jumping to the demo, about sort of BI, how it relates to Firebolt, where we've been and where we are now in the market. So if you guys are on Tableau, which is the poster child of self-service analytics, then I'm sure you've enjoyed what I like calling the golden age of in-memory-based self-service analytics. Tableau, with its amazing product, sort of grew to take on the market and change analytics forever, essentially by allowing self-service. It was the days when everybody hated data warehouses. Data warehouses were a big non-agile thing that IT controlled, and business couldn't get the reports they needed in time, let alone in an interactive way. And in memory, from a technology perspective, really enabled us to bypass that. So suddenly we could pull data out of the warehouse and interact with it and create reports that without needing the people controlling the warehouse to help us out with. And that was amazing. And that was the era where sort of really self-service BI took off with Tableau and with other tools as well. I myself worked for Sisense for many years, and we also enjoyed that era. Then over time, data volumes kept growing, kept growing, kept growing. And this is when we started to notice that, in memory has its limitations as well. In memory needs a lot of RAM. As data volumes start to grow, performance becomes an issue. RAM starts to choke. So that's one thing that started to happen. And in parallel, though, we did see an improvement in the warehouses. So suddenly the cloud data warehouses became more, more common, and they did allow for much bigger scales of data to be managed, but they didn't quite allow us to do fast interactive analytics over them. So if you were trying to connect Tableau Live to your Redshifts and still are to the Snowflakes of the world, we all know that it's slow. So what typically people end up doing is still using extracts. So we have all these warehouses that really can scale to larger volumes, but we're still using the memory technology because the live connectivity doesn't perform well from over the SQLs that the BI tools that Tableau generates. The SQL that Tableau generates can be complex, can be rich, can be join heavy, and the warehouses struggle with that. So we still have some journey to go on with. And this is where Firebolt comes in. So Firebolt is all about really unlocking sort of what big data promised us while enjoying what Tableau has always been doing for us, which is interactive analytics that's agile and that's sort of insight generating. So finally, we can really bypass extracts, connect the visualization layer, Tableau Live, to the warehouse and enjoy analytics that's super fast over volumes that we just weren't able to analyze in a fast way in the past. So benefits for Tableau users. So first, data is fresh. So by bypassing extracts, we don't need to wait those long, so sometimes hours for the extracts to be created. We analyze the fresh data that's live in the warehouse and lose that latency. And we can also start analyzing much bigger data sets that goes far beyond sort of what in-memory can handle. If you're in memory, then if you're analyzing, maybe if you're hundreds of gigabytes, that's okay. But once it gets closer to a terabyte, not to mention much more, it's tough. And essentially, once you go live with Firebolt, there's no limitation, and you can analyze much more data. And you can also analyze granular data, because what we often do to be able to keep using extracts is to aggregate data so it can fit into the extract. So no more either analyzing less data than you want or aggregating and giving up granular data. And lastly, it's also about not worrying about scale. Because if you're starting to feel your extracts not being as performant as they used to be, because data volumes increased, because complexity of analysis increased, then you're counting backwards. And with the elasticity that a modern cloud data warehouse like Firebolt offers, essentially you know that you'll be able to scale easily as your data grows while keeping that fast and interactive experience in Tableau that you expect. Okay, so now the next step is to actually see the product and the demo in action. So let's do that. Hold on a second. Okay, now I'm switching my screen share to show you a dashboard in Tableau. And soon after, we'll go to Firebolt, the product. But this demo essentially is based on a real world use case from one of our customers. They allowed us to use this data for demos. You can see that some of the data is sort of obfuscated. So in the top right in the account field, you see obfuscated data, and the same applies for the app name at the bottom left. But what this use case represents, it comes from ad tech, and it represents a company that analyzes, downloads, installs, clicks in applications in various regions and so forth. And it's used by typically customer success managers who enter the account on the top right and then analyze the performance of their particular account and talk to that about the client with the client and so forth. Now, this used to run based on Athena actually, but over time, as data kept growing, it became slower and slower, and it became more challenging to do the interactive analysis that people wanted. So let's see how this dashboard behaves. So I'm going to paste a different account ID here and click enter. And what happens is that the refresh you just saw happen almost instantly runs over a data set that is 17 terabytes big, compressed in Firebolt to 1 terabyte, more or less. So amazing compression rate. It has a big table that has 32 billion rows in it, but still I can interact with it super fast. So if I click the pie chart now to filter, for example, you will see that everything comes back very quickly. And this is very important note, non-cached, okay? And these kinds of interactions, now I can also sort of extend the time period, of course, to analyze bigger time windows, and it remains very fast, or select a variety of dates within the line chart here. And it returns almost instantly. You probably didn't even notice that something changed. Or let's change the account number again to a different account. So not here, I deleted it. Here we go. Okay, and you see I changed the account again and it came back again. And again, it's super fast. Now I do want to show you something else. And I'm actually, what I'm going to do is show you a level of detail function. So if I go to the app table, I want to see specifically the table here at the bottom and add a level of detail function. That's oftentimes in a live scenario can be very challenging from a performance perspective. So I'm going to create a new calculation here. And what I'm doing is I'm calculating the average of the installs for each campaign. And I'm using the include statement for the level of detail functionality. Clicking enter, and now it's calculating, and here it is on the right. So very fast, comes back again, even as your queries the Tableau generates become more and more complex. Now let's see, how this looks like from within Firebolt. So we want to do a new share and go to Firebolt this time. Okay, so now we're in Firebolt. This is the Firebolt environment, and we're looking at the SQL editor in this case. And what I have open here is the query that Tableau generates when we run that, particularly for that bigger table at the bottom, which is the more complex query in the dashboard. And it selects data from this LTV table, which is a 32 billion row table, like I told you before. Let's actually do a select star from LTV to show you the number. We see the schema here on the right. And as you can see, that's 32 billion rows. If I do a show tables command in Firebolt, then we can see that here at the bottom, you see that it's a 17 terabyte uncompressed data set compressed to a little bit over 1 terabyte. Now, so we are querying here the LTV table. We're also doing a couple of left joins. And here you see the variety of filters that the dashboard had, including the media source string comparison that happened. And if I run this, then this returns, super fast, 0.26 seconds. And even if I, change the dates, the filters, it will still return very fast. So it's not cached. And even, in this particular case, I'm filtering for a specific media ID. So let's just comment this out and essentially scan across all the media sources, and that will also return very fast. And that might look like magic, but let's now actually go back to the presentation so I can explain how we do that behind the scenes. How come Firebolt is so fast? Okay. So back to the presentation. How come we're so fast? So we have a very rich technology stack under the hood, and I'll highlight some of the things we have going on there. But essentially, you could split our technology stack in two. To tech that is centered around the storage layer in the cloud, which is a huge bottleneck in its own. So in the cloud, we can enjoy the infinite scale of storage, but we also have to take into account that it's a slow storage layer, unlike in memory, which is very fast. So there we have to deal with things like, how do you store data? How do you compress data? How do you index data? And how do you move it efficiently to the faster storage layers to avoid bottlenecks? And the second set of technologies is more about the compute, which is how do we utilize the CPU to maximize throughput, particularly for analytic workloads, which is aggregations, joins, indexes, things like that. So one important building block that is unique to Firebolt and we have under the hood is our own proprietary file format, which is called FFF. When we pull data into Firebolt from your S3, essentially it's converted to this file format as it comes in. And this file is always physically sorted. In Firebolt, for every table that you build, essentially you define something that is called a primary index on top of it, that can be defined over one or multiple fields, which literally defines the physical sort order of the file. And then the file is indexed, which academically, that type of index is called a sparse index. And the sparse index, what it does, it works in a very tightly coupled way with the file. And it tells the incoming query where from within the file to fetch to scan the rows in. Only the rows that actually participate in the query. And what it does is dramatically reduces data scans in both S3 and the faster storage layers compared to other query engines. And in the product, we literally show you how much data was scanned for every query that you run. Not just how long, but how long it took, but how much data you scanned, because it's a very big deal. So essentially, Firebolt uses indexes in a very unique way to make sure we scan much less data, and that makes queries much faster. On top of that, there's a variety of CPU-oriented technologies. Our cost-based optimizer is very important to understand why Tableau is fast. So, when you write your own SQL queries, oftentimes there are a variety of techniques you can use to make your SQL faster. But at Firebolt, our product strategy is all about making even ugly SQL run super fast. That doesn't mean that Tableau generated SQL is ugly, but you cannot control it. And Tableau generated SQL can be very complex. If your data model is big, if it has multiple tables in it and there's multiple joins, and not to mention complex functions. And that's why it has the potential to be dramatically optimized. And this is what we do behind the scenes. On top of that, there's also the vectorized processing technologies, which is all about leveraging the columnar database under the hood and how it works with the CPU for maximum throughput and just-in-time compilation. All of these things combined really give you a performance boost that you start noticing very early on. But this is not it. Typically, what you see here are all the things you don't have to worry about as a user. It's all behind the scenes. What we do offer even more advanced tools to optimize things even further. Typically, when you take sort of dashboards to production or start to share them with different users, many of you said you're using a BI for customer-facing use cases. This is where concurrency starts to grow and performance becomes even more of a challenge. So there we have more indexes that you can use to accelerate performance. The first one is called an aggregating index. This type of index is especially useful when you know which dimensions and measures people will be looking at, meaning classic for dashboards. So in a Tableau setting, the typical workflow is that you start, let's say you're an analyst and you start building out a new use case, you don't put an aggregating index in place. It's an iterative process. You first need to get your queries right. But let's say the dashboard is ready and you now want to share it and you know it will be reused consistently by others. Then you say, okay, let's optimize it a little bit further and let's put an aggregating index in place. And what it does is that once queries come in, you keep querying the tables as usual, but the query engine knows if there's an index attached to the table, and if there is, it can use it and accelerate the queries even further, typically sub-second for huge data sets. But not only does it make the queries quicker, it also makes them much less CPU hungry, which means you can typically even make your clusters smaller and enjoy better efficiency and smaller costs for compute. Another type of index we have is called a join index, which is, like the name implies, used for joins. And if and typically you do have joins in Tableau, and we typically don't tell you to denormalize your schema, but use join indexes, and that really gives a boost for joins. So today in Firebolt, essentially you have to manually define these indexes. It's not complex, it's easy, but part of our product roadmap and our vision in general is to really automate many of these things and to start giving you recommendations on which indexes would benefit your workloads and would increase your efficiencies. Now, let's talk about the Firebolt architecture and look at it from a bird's eye view. So what you can see in our architecture, and we'll soon go back to the product to see how it affects your usage of it, but you see the compute layer in the middle, decoupled from the storage layer at the bottom. In the storage layer, you see the database is persisted to FFF format and the indexes as well. And in the compute layer, you see those boxes called Firebolt engine. In the Firebolt terminology, a Firebolt engine is the cluster, is a compute resource, a cluster of compute that runs the queries essentially. And for each copy of the database, you can have multiple such engines. Typically, you start with a two-engine setup, one for data ingestion and another one for querying. But the nice thing about the decoupled storage and compute architecture is that it allows you to mix and match different engine types. Each can have a different size, different configuration, can be shared with different people, and they don't compete for resources. So each one has isolated resources that can guarantee consistent performance and so forth. So for example, you can have one engine that's for sort of a development team experimenting with new use cases, another engine pure for production and customer-facing use cases, and there won't be any races for resources, and all of them work on one copy of the data. Firebolt is also fully SQL compliant, so the SQL that comes into Firebolt, you can see the variety of clients at the top. So Tableau comes from the JDBC connector. We also have REST APIs and support other API tools and so forth. Now, let's go actually back to the product now. Just a second, please. Uh, uh, Here we go. So now I'm going to show you the more decoupled storage and compute from within the product. I'm going to click the databases page here. And what you can see is a list of databases, but take a look at this AdTech DBv4 database, which is the database we used in Tableau just now, and see that it has multiple engines attached to it. If I click Edit, then I can see the list of engines and add as many new ones as I want. And when I define an engine in Firebolt, on the right are the settings. And you can see that, for example, this slider lets me choose how many nodes I want in my cluster. And just, as your data grows over time, you need more firepower, add more nodes, a few clicks away, no migration projects, no vacuuming of data, just point and click. Something that's also very unique to Firebolt is if you want to optimize further for a little bit more advanced control, you can even choose sort of more granular compute types. So for example, you can say, I wanna have a machine with double the amount of RAM, for example, or double the amount of SSD storage. Oftentimes in the cloud for big data settings, just increasing the amount of nodes stops being the best way to accelerate performance. Every query can enjoy distribution only to an extent. Sometimes adding more SSD or RAM also has a dramatic effect on performance, and oftentimes at a better price point. And now, if I go back to the query editor, which we saw before, and this is the query we ran before, you can also see that I can dynamically choose which Firebolt engine I want to run this with. So I will switch to a slightly cheaper engine, and it might be a little bit slower, but I will also pay less for it. So now instead of 0.20 something second, it's up to a second, but it also cost me less than half the price. And this is sort of the nice thing about the decoupled storage and compute. You can control how much you're paying and in return which experience you're going to get. And you don't always have to use your biggest or most expensive cluster. So typically you can say, if I'm building out a new use case, maybe I'll start with a cheap engine, and I'll only start working on the last week of data. And once they get my queries right and the dashboards in Tableau looks good, then I will switch to a more expensive engine and analyze a month of data, a year of data, and so forth. And at any given point in time, you know how many dollars you're paying per hour for that compute. And you're only paying for as long as the compute resource is up. Okie dokie. Now, I do want to go back for a second to Tableau as well. I don't know what happened before that it didn't return. I want to show you something else here. Now, I did want to talk about granular data. If I click a particular row in Tableau and I try to look at the raw data, then the idea here that it doesn't take long. So even drilling to detail and seeing all the data behind the scenes is still available. So I don't have to aggregate data. I can keep analyzing the granular data set and have that available to me within a few clicks. Okay, now back to the slides here. Let's talk about the pricing model for a second, and the efficiency I mentioned is a big deal and a big differentiator for Firebolt. So first, you saw in our user interface that you can always see the prices of the engines that you're using. Our approach is very transparent. You always see the prices in the user interface, no hidden fees, and it's a pay-as-you-go model. Essentially, when the engines are up, the price that you see in front of you is what you pay on a per second basis, and when they're stopped, you're not paying. You're also paying for storage, but we don't make any markup there. So it's the AWS S3 price, which is $23 a terabyte. So super marginal. But at the end of the day, Firebolt introduces huge cost savings. And it's not because Firebolt is cheaper, it's because Firebolt is more hardware efficient, which is enabled by the technology. We know how to deliver faster analytics with less hardware, and that's where cost savings end up coming from. So oftentimes it can result in both a reduced bill from compared to what you're used to, but more importantly, oftentimes it enables or unlocks use cases that were out of reach before. If you were planning to do a sort of interactive analytics experience over huge data sets and you weren't able to because whether in memory couldn't handle that or you needed a cluster or a machine that was very expensive, suddenly it becomes reasonable with Firebolt, and we see that all the time. I do want to show you sort of a typical outcome for Firebolt POC. So Firebolt typically, we typically work with companies that are rather mature in their sort of cloud DNA and data DNA, meaning they typically already have a data stack in the cloud and big data challenges. And then, we ask you for access to data in S3. And we ask you for a few examples of queries that you send to your warehouse or query engine. And we ask you, which kind of cluster are you using and how much are you paying per hour? And then we, show you how we do that with Firebolt. And it can be just with the SQL itself or through a Tableau dashboard. But what we always see in a very consistent way is both a huge boost in performance, but also typically combined with sort of a smaller cluster and hence less dollars spent per hour, like you see here. And that's about it. This is now time to answer a few questions.
Okay, that was great, Boaz. Thank you for that. Just before we get started, there's one last poll question. So before we move on to questions, I see there's a lot. So last poll question for the day. Coming up. Would you like to check out Firebolt? It's obviously just making fun, but seriously, if you do want to dive deeper and see how Firebolt, if Firebolt is relevant for your specific use case, then by all means, would love to do that and take you through how this works. So many people are asking, if they're going to get the recording. So yes, you will get the recording. Don't worry about that. So that's that. How can we get our hands on Firebolt? Is there a trial environment I can access?
So I can explain that. So the way to work with us is to contact us. So today we don't have yet a self-service environment where anybody in the world can sign up and play. Being sort of more recent into our entry to the market, we're a little bit more selective in who we work with. The idea is to work with companies that have more of a bigger data challenge. We're AWS only as well, so keep that in mind at this point. If you want to try us out, reach out to us, and we'll kick off sort of a joint POC where we can sort of help you get started with Firebolt and show you how to use it with Tableau in the best way.
Okay. So another question is, at what size have you seen Firebolt becoming faster than an extract?
So, typically people come to us when extracts are slow. If you have a data, everything's fine for you with extracts and everything works, everything's great, typically it might indicate that it's maybe too early to talk to Firebolt, and if there's no pain, then there's no need. But typically we see that starting from a few hundred gigabytes already, actually sooner than we expected when we started this journey, things become slow. What actually took us most by surprise is how nobody, and we talked to dozens and dozens and dozens of companies, nobody over Snowflake or Redshift uses live connectivity. And the reason oftentimes we hear is that it's either too slow or requires machines that are too big and are therefore too expensive. So you invest a lot in that modern data warehouse, but end up using extracts, which do limit you. you have to wait for the extract creation. And as data keeps growing, the extracts become slower. So in memory in itself, is a great technology because, RAM is fast and typically performance is fast, but not when you start to take it really to its glass ceiling. And that's where things become slow, it becomes a big pain. And this is finally sort of the reemergence of cloud query engines that now are, thanks to technologies like Firebolt, can be faster than in memory.
Good. Another question is, how does Firebolt work with Tableau's SQL?
So like you saw in the demo, it works very well. We invested a lot to be able to be in that state where we can make Tableau queries performant. That journey included, understanding the SQL that Tableau generates and building many optimizations in our SQL optimizer to specifically take care of Tableau generated SQL, including complex functions, like level of detail functions, and so forth. And that's how we can enable that kind of experience.
Okay. Balu is asking, will there be an API available to push data into Firebolt and pull data as well as using our custom applications?
So Firebolt is very developer friendly, and everything can be automated and done programmatically via our REST APIs. And from our REST APIs, you can also do everything we showed you in the UI, even through SQL commands. So for example, creating a new Firebolt engine and dumping it is a create engine command. So everything can be done programmatically. And also we do customer-facing use cases very frequently. Customer-facing use cases often are dealt by developers who need that kind of programmatic access, and this is why we deliver it. And funnily enough, the customer-facing use cases are interesting because historically, data warehouses were not the go-to technologies to power these use cases, typically because they were not fast enough and didn't deal with concurrency enough. So if for internal analytics, if a query takes, I typically say if a query takes 15 seconds for an analyst, nobody loves it, but you're not necessarily willing to spend a lot of money to solve it. But for customer-facing experience, we need that very fast performance to create great interactive experiences for our customers. We do not want our customers to wait 15 seconds. And Firebolt, because we're so fast and with the decoupled storage and compute architecture, that lends itself amazingly well to these use cases as well. And it includes everything, programmatically controlling everything.
Good stuff. What else? What are the main differences between Firebolt and Snowflake?
So there are a variety of. So first of all, in terms of the market today, Redshift, BigQuery, Snowflake, Athena, and others, we're definitely most comparable in terms of architecture to Snowflake with a decoupled storage and compute, and you'll be able to control your resources. But there are a variety of differences. First, speed. Firebolt is dramatically faster than Snowflake. I showed you that in those sort of POC results that we saw here. So while our decoupled storage and compute architecture might be comparable, under the hood, it's very different. They have micropartitions. We have our FFF file format with indexing built in, a lot of use of indexing. Also, our approach to product is a little bit more, allows you more control. So while Snowflake is a great tool and it's very simple to use, your only knob essentially is the size of the warehouse, small, medium, large, extra large. We believe in giving you a little bit more control, so you can oftentimes even optimize further with things like controlling sort of more or less RAM or SSD size, for example, and more types of indexes, so you can optimize further. And also cost efficiency. So because we're so hardware efficient, you can run faster queries over more data while still paying less compared to Snowflake. What else is stuff? I see a question around getting data into Firebolt from BigQuery. So we do not run on GCP, but we do see customers sort of you're on a multi-cloud strategy and are using BigQuery, but have AWS as well. So if you can use an ETL to pull data from BigQuery into S3, and we can pick it up from there. So there's no sort of direct point and click way for us to do it with, but if you build a pipe to bring data to S3 on AWS, then we can take it from there.
Good stuff. look, there's more questions, but we need to wrap it up. So thank you everyone for joining us today. Please, follow us on LinkedIn, and you'll get all the updates of what's going on with Firebolt. And thank you for taking the time. Thank you, Boaz.
Thank you so much. Thank you everybody for joining us.
Bye, everyone.